right, so now we've showed you a compression test, both static and wet, and now what we're going to show you is a leak down test. So the leak down test will test the valves for integrity and see if there are any leaks. All right, so what we have to do is, our first step, we obviously start with all the spark plugs out like we did last time. So this is one of those things where if you're already doing this test and you're going to do a static and a wet, just move straight into this and do a running compression later, which we'll cover in another video. Okay, so this right here is your leak down gauge. Now the way this works, pardon me, the way this works, okay, this is your input pressure. So we're going to dial it up to 100, and that's going to bring this gauge right around to 0. That's our set point. Okay. Now, for every pound of pressure that we lose through this engine, it translates into a percentage because we're using 100 psi as our input pressure. So whatever this goes down to is how much we're losing. Now, the one thing you have to remember is we're going to have to move the engine mechanically up to number 1, okay? And not just number 1, but number 1 compression, and number 2 compression, number 3 compression, etc. And the reason we have to do that is just pushing down on the piston with the air, because we're going to use air pressure from the shop, just by doing that, it rotates the crank, which rotates the camshaft, which actuates the valves. As soon as you actuate the valves in any way, shape, or form, you're no longer on compression. You may be on exhaust, you may be on intake, okay? So that's what we're going to do, and I'll show you how to do that in just a minute with a big breaker bar. So let's set this up first. And we have our compression hose, the other thing I want to show you, okay? In the other test, okay, we used the same compression hose, but we had a Schrader valve in it, okay? And one of the important things you want to know about Schrader valves is, of course, they come out of tires, okay? So if you have a gold one in here, don't use it. A gold one will always be for a tire, okay? The ones that they use in here have extremely light spring pressure, and they are silver, okay? So they should be in that kit, in the compression gauge kit itself. So if you have a gold one, make sure you pull it out and swap it out to a silver one. What will happen is you will get extremely low readings when that happens, okay? So what we've done this time, because we want to apply air down this tube and into the cylinder, where we can roll our ratchet around and force that piston up on compression and force that cylinder to hold pressure so we can measure how much is escaping, we've removed it. All right, that's one important thing. When you're doing a leak down test, that has to be gone. If it's not gone, you won't be able to push air this way into the cylinder because it only opens this way, okay? All right, with that out of the way, put this in number 1. And then we'll set our gauges up right here. Okay? Now this has a regulator on it, so I always run it all the way out just to get started. Also know that these sometimes will retain pressure. So if you go from one cylinder and you disconnect it and they don't return to 0, or our set point over here with no pressure applied, just give it a few seconds and 9 times out of 10 it'll bleed off. So now what I'm doing is I'm applying pressure into this cylinder, okay, against that check valve, all right? So we're gonna get our set point, and once we get to our set point, we'll connect our check valve to our hose, and our hose will put the air in the cylinder, okay? So, we'll wind this up, and just beware, if you get to a certain point and it quits going up, just stop, because all of the components inside here are plastic and you'll just ruin it. Okay, so as you can see, I overshot it just a hair, but now we're at 100 and this is at 0. So this is 100 psi applied. Okay, so for every pound here, we have 1 percentage point over here that represents, okay? 1 for 1. So now what we're gonna do is we're gonna go ahead and connect it here, okay? And now you can see, right, we have 90 PSI here, and we are leaking 90%. Does that make sense? We've dropped 10 pounds of air input, and we're losing 90% of the air that we put in the cylinder. Now the reason for that, as we discussed, is it pushed down on that piston, rotated the crankshaft, and through the timing chain, moved the cams. It's my job now to roll the crankshaft up using the harmonic balancer bolts until we get a seal, and then we'll be able to get our reading, okay? I'm going to show you how that works, and I'm going to explain a couple things about what to do and what not to do. So as you can see, all right, this is a big bar, 30 inches long, all right? We also have a long extension so that we can get all the way in to that crankshaft bolt and then spin the engine over. So you're going to know really quickly when this starts to compress. And the reason I say that is it's very easy to move right now, but when you come up on compression, you're going to be working against shop air, and it's going to change just like that. Just like that, we got tension. There we go. Now this particular vehicle is kind of tired, so it's pretty easy to overshoot your mark. Okay, newer production vehicles are not going to be like this, right? Just so you know. So I went right past the full compression stroke because this engine is tight. Now, one thing you're going to want to know is you'll understand that right here I'm stabilizing this whole rig with my left hand. And the reason I'm doing that is because if something happens, I don't want to get clobbered, okay? Now, this bar right here has all the energy of the shop air behind it. On this engine, not such a big deal. You can go right past it just by leaning on it. On any of the other newer cars that we'll have you guys test on, that's not the case. If you lose your grip here, or if this pops off, this can come back and smack you in the face and really hurt you, and I don't want that to happen, okay? I love all my students. Maybe not equally, but I love them all. Or maybe for different reasons. Anyhow. Christian. All right, so at this point, I'm gonna hold this right up against the compression of the engine, okay? So right now, we're on the compression stroke. The piston's coming up, and the four valves, pardon me, on this engine, they are not down, they're up. So they're all sealed into the head. So it's not supposed to let any air out, all right? So when we come around, ideally, we're looking for a perfect seal. We're looking for 100% no leakage. Now, in the real world, that's not gonna happen. I'll just tell you that, okay? What you wanna find is equal leakage across the engine, okay? And they'll give you a spec, they'll say don't have more than 30% leakage, blah, 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 whatever. What it boils down to is, if all of them are within 5 or 10%, if the engine's tired, the engine may still be okay, you may be fighting another problem from this fire, okay? So then you'll have to check further. But this engine in particular is pretty loose, and we're gonna see some leakage, okay? Christian, if you don't mind, come on over and get a picture of those gauges for me while I hold this. So as you can see, we really don't have that much leakage. We've got about 15, 16, 17%, somewhere in that neighborhood, Christian?
Sir.
Okay, so that's good. That's really good. That's a cylinder that works the way it's supposed to. All right, so I can disconnect all of this rig right now because that cylinder passed. Remember, this is the cylinder that had a good compression. So if it has good compression, now we've verified that the rings are doing their job and the valves are doing their job, okay? So, next step, we disconnect it here. We can leave this here, all right? And this is what I was talking about. If we disconnect this, those return to zero or very near zero, but not always. Sometimes they will hold pressure for a little bit and then they'll bleed off. So just be aware of that. So, and this is a case where I've just put a little more twist on this regulator, but these aren't moving, so I'm just gonna leave them alone. So what you wanna do is, if we're off by about 7% here, then you use that as your new 0 point, okay? So if we read 20%, we have to add 7 back to it. Does that make sense? So we'll have 13% leakage. So now we move on to the next cylinder. Okay. Now remember, a leak down test tests for all of this stuff, and we'll discuss how to check for it here in just a couple of minutes. I'm more interested in showing you the numbers right now, and then we'll discuss where to check, how to check, and what that means. All right, so now as we first hook this up, we've got about 75% leakage plus our 7, so we're at about 70% leakage, all right? Way down in the red, obviously. No big great deal, as long as it comes up when we roll that number 2 piston up on compression. If it doesn't come up on compression, then we have a problem. Okay, so, and depending on your firing order from one cylinder to the next, it may take you a little bit to get to the next cylinder. So you may have to roll the engine halfway around before you come back up on that, or maybe 2 times, right? Because the cams spin at half the speed of the crankshaft, right? All right. And this engine's firing order is 1, 4, 2, 3. So at that point, I may have to go a little ways before I get number 2 compression. There we go. Okay, we're starting to come up. That's as far as we're going to be able to go. You want to get a picture of those gauges, please, Christian? So what we're looking at right now is we're looking at a tremendous amount of leakage, aren't we? So if you read the green, yellow, red, we do not have a healthy engine, okay? I can move this bar and that needle doesn't change. So we have a tremendous amount of leakage. Can you read it for me, Christian, please? I can't see it.
So you have about 80%, close to 80% lost.
Okay, close to 80% lost. So if we had 7% to begin with, we're about 75% lost. So if we're losing 75% of the air that we've added to it, then at that point, on compression, we have a giant problem. And what did we notice when we were doing our compression test? We noticed this was 150 or 145. This one over here was about 95 PSI. Okay, we've lost a tremendous amount of our compression, 1/3 to be exact. So it's not a big surprise that we're losing a bunch of air from that cylinder. Now we'll go ahead and check number 3 and number 4, and we'll see what our readings are, and then we'll discuss how do we diagnose this. Okay? All right. So again, we're off by about 15% on that gauge now. It's just going to get worse unless we bleed it off. So in this case, I'm not going to worry about it too much. On a customer's car, especially for manufacturer's warranty, I would want to know exactly what that number was. Okay? Okay, here come the gauge readings. Where are we at there, Christian? That's as much as we're going to get.
About the same, 80%.
80%. So we're losing 75% of our applied air pressure somewhere, right? We haven't determined where yet, but I am going to show you how to do that. We're going to check number 4 and make sure that this follows that if we have good compression, we should have low leak down. And as long as that's the case on number 4, then we'll come back to number 3 and we'll discuss how to check for where all of this air is going and what that means, okay? this is off by 20%. We'll look that up. Now, one thing you guys can't hear at home, we're adding air to the engine. Now, one of these things that happens when you add air to the engine is, until you get the valves closed, it escapes the engine. So as I'm turning it, I can hear that that area of where it's escaping has changed. All right, Christian, you want to get a shot of that, please? Based on the fact that we started at 20%, we have about 7% leakage, don't we?
Yes, sir.
Perfect. So that cylinder is what?
It's good. It's
Good. Fantastic. Fantastic. So, since that's the case, our leak down numbers are following our compression numbers, aren't they? So if that's the case, then the ones with high compression should have low leak down, and vice versa. Okay? So now we're going to go back to number 3. Actually, let's go back to number 2. And then what we'll do is we'll walk you through what to listen for and where to listen for. Okay? So what we'll do, we'll go ahead and apply our air. I'm going to roll this around to the dubious point of compression that this actually makes. God bless Sweet Silver, that's the name I gave the car. She's a sweet girl, she's tired. She's going to go to the auto mall in the sky at the end of this video. So God bless her, she's done a great job for our students. Terrific job for me. She's been a beautiful teaching tool and I love her a lot. But it's her time, she's getting tired. Okay, so if we look now, all right, at our numbers, we're still losing what, like 70% there, Christian?
Yes, sir.
Okay, so if we're losing 70%, now the beautiful thing about this is since we're losing that much, this will probably mostly just stay where we want it. Now, here's what we're going to do. We're going to listen right here at the oil fill cap. Okay? Kristen, can you just run the phone down there, please, so that we can get the microphone near that? Now, what you're going to find is you don't really hear anything there, okay? Now, the other place you need to look, Christian, if you'll, I'll actuate this if you'll move that down by the throttle body. We have a little bit of air coming out of the throttle body, all right? So if we're going to diagnose the engine this way, if we have a whole bunch of air coming out at the oil fill cap, then we're looking at rings, okay? We have some coming out over here at the throttle body, that will be intake valves. So the other place you'll listen is at the back and you'll check the exhaust. Okay, you'll put your ear, your stethoscope in the exhaust and you'll listen for noise. Now, the biggest thing about this car is you'll hear a little noise here, next to none here, a little bit out the exhaust, but the main place you're going to hear it is in the next hole over. Go ahead and hold the phone down there, Christian. Let's see if we can get a microphone shot of that. Yeah, so show them what we're looking at. So that right there is the number 3 cylinder. That's where we're losing all of our air, okay? So if you're losing all of your air in one cylinder next to the other, you're dealing with a blown head gasket, okay? That's the one reason I lobbied to save this car, and it's the reason I'm making this video. You don't see this very commonly necessarily. Not enough to be able to have one just hanging around the shop to demonstrate with, and now this car has reached the point that it's going to have to go away. So that's why I'm making the video, so that I can continue to show you what this looks like instead of just talking about it. Okay, so we have a blown head gasket between 2 and 3. So when 2 comes up on compression, the gasket sits here between this piston and this piston. What happens is it comes up, over, and down into the number 3 hole, okay, the number 3 cylinder. When that happens, we create a misfire because we only have 100 PSI worth of compression. When number 3 comes up, okay? It pushes right over that gasket and into the number 2 cylinder, and it loses a third of its compression as well. So that's how you're gonna find it. Now my recommendation and the way I usually do this is I use a set of stethoscope, and if you have the metal ear for it, or the metal attachment with the rod that allows you to diagnose vibrations, take that out, okay? Listen here, listen here, listen at the tailpipe, and then listen in both holes on either side, especially if you have low compression, one hole to the next. 9 times out of 10, that's a blown head gasket. And a lot of times when you pull it, you'll find that the head has a warp in it. It's got a big bow in it. And it can't compress that gasket to hold that pressure. So that's where we're at. This is how you do that test, and that's how you diagnose your results. So I hope this helps you, and you guys have a great day. Christian, thank you again.
Sir.